When we hear the words artificial intelligence, we often picture a single, glowing, all-knowing digital brain that somehow understands everything all at once. But inside the technology, you won't find a single brain. You'll find this: a sprawling web of highly specialized tools and problems, each operating in its own little world. We can think of this whole field as a giant schoolhouse. Inside, there are thousands of distinct students, and each one is training to do exactly one specific job. To teach these digital students, a developer has to make two choices. They have to pick the right teaching style and then provide the exact right set of study materials. Understanding AI is a matter of seeing how these specific study materials get paired up with the right teaching styles. Let's step into the busiest classroom in the building. It relies on a teaching style called supervised learning. This works like flashcards. On one side is an input, like a square. On the other is a clear label acting as the answer key. The student guesses, then flips the card. If wrong, it mathematically adjusts until finding a correct match. This reliable, step-by-step method is how we teach computers to sort files or predict a trend. But even the best teacher can't help a student who is holding the wrong textbook. Because these digital students are so specialized, they can only learn from information that is formatted exactly for them. Just as a history student needs a map and a math student needs a calculator, AI models require completely different formats of information depending on the task. To predict numbers or sort files, we use tabular data, essentially a giant structured spreadsheet. Because the numbers sit in clean columns, the computer scans thousands of rows to find statistical patterns, sorting them into the right bins. But a spreadsheet is useless if you want to teach a computer to see. To do that, humans have to painstakingly prepare a different kind of material. For vision tasks, we use raw images paired with color-coded masks, highlighted pixel by pixel so the computer knows what to look at. Other tasks have unique requirements. Translating languages uses side-by-side text, while speech recognition requires raw audio waves. The physical format of the data you provide dictates exactly what kind of real-world problem the computer is capable of solving. However, humans don't always have the time to hand-label millions of images or create answer keys for every single flashcard. Instead, we use self-supervised learning. Imagine reading a sentence and blocking out the final word with your hand, guessing it from context. By hiding information from itself, the computer creates its own answer keys, learning from massive amounts of raw text without human labeling. Finally, in reinforcement learning, the computer navigates an environment through trial and error, hitting walls, losing points, and trying again until it finds the path. Removing the need for a strict human-made answer key allows these systems to adapt to messy, unstructured information that would be impossible for people to organize by hand. Returning to the map of the AI landscape, we can see it isn't quite as intimidating as it first appeared. We can organize the entire field just by looking at the teaching styles and the study materials, like the spreadsheets used for predicting trends or the images used for identifying objects. This also explains a major reality of the field. Experts actually spend 40% of their time strictly on data preparation. Because AI relies on specific study materials, the majority of the work isn't in the math. It's in the human effort of cleaning, sorting, and labeling that data so the computer can understand it. Artificial intelligence is a disciplined process of matching the right data inputs to the right teaching methods. When we get that pairing right, we can solve